and we do well to, we have this central printing machine, because we always preach keep green, and all staffs have a particular card, personal to yourself. If you come, you print, the machine keeps track of the number of printing you do and how the number of, keep the calculation on everything that, the printing. And we always try to you reuse papers at all times. That's keeping green and, being valuable.
Yeah. Very good. That's fantastic. Thank you very much for that, Jimmy. Chris, take it away from the last class.
Okay. Good evening, class. My takeaway from the last class is about the IFMA 8 major sustainability, and how it was broken down to 3, where we have the input, process, and the output. The input have 3 processes. The process has more, and then the output has 2, which has to do with water and code. Thank you.
All right, thank you so much. That's fantastic. Femilaba, please go ahead.
Yes, good evening. The figure of the last class was on the energy efficiency uses. The key point which stands out for me is that you cannot improve or manage what you do not measure. Measure every energy use that goes on in your system.
Thank you. That's fantastic.
Good evening, all. From the last class, one thing I picked was the necessity for a sinking fund, which we're supposed to use for the replacement of our equipment. We find out that in most facilities, we expect that we will use the service charge to replace equipment, but it doesn't work. And that's why we have machines, equipment that just stay on, they're dilapidated, and we keep complaining. They reduce our efficiency and all that. So once the project takes off, we must, from inception, have a sinking fund. Maintenance and for replacement of the equipment. That was what I picked.
Fantastic. Thanks a lot, Tosin.
Thank you.
Yes, thank you, sir. Good evening, sir.
Good evening. Welcome.
Yeah, mine too. The energy management earlier. The purpose of energy management is not the purpose of energy management is to improve energy performance, not to reduce the energy consumption. And that what is important is that you continue to improve your energy performance as you increase your energy consumption, and also that to improve the performance, which can also be measured in cost, absolute use, with various energy and ratio of use, such as the kilowatt hour per unit, and so on. Then ensuring that, like what I've been doing anyway for our own place is to cut off that shutting down equipment that are not in use. We have a large space that because of camera, we had to, because there's a hall we have, the security will say they want the place lifted up so that the camera can see. So now I'm telling them we need to install cameras that can I've forgotten the spec.
I can see through the dark, right?
Yes. So that we can reduce that consumption, that low, as in just the light comes at that.
And then there's something else again you could help them to do. You could put motion sensors on the lights that you want to save energy on, right? So the camera, if they can't change their camera, you can help them with motion sensors. So the camera will come on when there's activity. So if there's no activity, the light will come on when there's activity. When there's no activity, the light will not come on. So that's where you can control your energy consumption there.
Okay. All right. Thank you, sir.
Welcome.
Then also the bulbs that are of 4 wattage, we are reducing them now to something like that, to all these LEDs.
Very good.
No.
Very good. Don't forget to do the study. Take your light intensity that is comfortable and then check against the ones you are installing. So you don't provide too much light or too little light. Remember Vianana's comment last week. Okay. During the class rather. Moses.
Thank you, sir.
You're welcome. Moses, you can take the mic now. You can unmute. Moses doesn't seem to be hearing us. Kingsley, can you please speak now? Kingsley, what happened to your mic? Yanana too. Who's there again? Why are you guys putting off all your videos rather? Let's talk. Put on your videos. Let's talk, face to face, not
Good afternoon, sir.
of the class. After 10 minutes, you can begin to save your data. It was Kingsley I called to speak. The camera is off.
Okay. Yeah, good evening, sir.
Good evening, welcome.
Yes, sir. My own take in last class is on the concept of load shedding and then load shifting. I think it's a concept that will help us to manage energy more efficiently and then taking into consideration the peak and the off-peak period. So that is my take.
Very good, thanks for that. Moses, you can speak now.
Good afternoon, sir. And good afternoon to everyone. My take from the last class was the fact that the FM in any built environment is supposed to lead in these sustainability procedures or steps in that organization. I came to see oftentimes we use the word FM leadership, FM leading, and that brought to my mind that the FM is supposed to lead and take the lead. You need to take the lead by allowing, convincing management, making a case, a business case for them to see why they need to key into these sustainability procedures to save the environment and of course to improve the living conditions of the residents of any building. They need to get management to come in. They need to, now it's actually in the practical steps towards a sustainable future now, they need to also collaborate with other team members and see how they can buy them in. The FM in any organization is just like a small politician. You need to see how you can get the right stakeholders and let them buy into the concept of sustainability and see how you can bring it to play in that particular organization. And also, thirdly, whenever there's a milestone or whenever there's an achievement, there's no harm in congratulating yourself or in celebrating the team, just in a way of motivating them. Yes, we are able to reduce the consumption of paperwork from so number of rooms in a month to so numbers. And also to put all these metrics in written form and also let management know what you are saving in terms of cost, in terms of Naira and Kobo. It will really drive in the points. Thank you very much.
Fantastic. Thank you so much, Moses. That's fantastic. Francis, let's hear from you.
Good evening, sir. Good afternoon.
Welcome.
Yeah, first off, sir, I'm in a very noisy place. The apartments next door, they are doing a communication, so you may not hear me clearly, and I'm not feeling too well. Let's quickly say this.
No problem.
I used to think that sustainability is just about you. That is the procedure, the plans you use to sustain what you are doing so that it continues. But from the last class, I got to realize that it's more than just you. You have to do for you and for the future generation so that they are able to use that same thing to operate during their own time. That's a very good point that I got. And concerning the asset replacement funding, the lady that spoke now just said it's a sinking fund. Is that correct, sir?
It is correct, yes.
Okay,
that's what that's using sinking fund.
Yeah. Okay, it's a sinking fund. All right, okay, sir.
Yeah.
So that's my take on last class. Thank you, sir.
All right, thank you. Emmanuel T.
Good evening, sir.
Good evening.
Good evening. Yes, okay, so my take home from my last class is just always make sure that we use less of energy. I set an example for a secondary school about the energy consumption for AC. That during break time, that they put stuff when they are back from breaking. So anything we are using, and as a facility manager, I need to understand the building and know where the most energy consumption inside the building is happening. So that's my major take home, sir.
Excellent, thank you. Maiwa.
Hello. Good evening.
Yes. Good evening.
Good evening, sir. Good evening, sir. Actually, I didn't finish the class last week, but I took some things on that was very, very vital. Okay. The first thing is that as a facility manager, our the way we try to sustain things should be very, very it should be one of our like a good aspect of our something. In terms of sustaining, that is, we should make sure we use things right so that it will not suffer the next generation. And also, okay, and also in terms of management of energy, also, you talked about something that we should in terms of meter, so that we can measure the amount of energy we are using, so that we won't just be cheated by the NEPA association. And also, I want to add to what Moses said. He said leadership, and also we trying to enlighten our fellow workers on how to maintain and then sustain energy, in terms of not putting on things that are not necessarily in use, so that we will not just waste energy like that. And also the sources of energy too, sir. Thank you, sir.
You're welcome. That's good. MM, are you here? Can you speak?
Good evening. I wasn't in the last class, so.
Did you get the material? Did you read it?
Okay.
It's muted. Okay, let's pass on MM and go to Bianana, please. Bianana, take the mic.
All right, thank you, sir. Okay, thank you, sir. Sorry, I had issues with my network. In fact, I just tried to connect with my phone and the signal wasn't too good. That's why I took off my video. For the last class, I think for me, the key thing is on sustainability. And readily, I could see the application in a process I've been asked to intervene. In our catering process, I see that we are generating so much waste. And at the back of my mind, I'm asking myself, this kind of catering process, is it sustainable? Can we get people to come and eat plated meal? The worst case, if we say people are busy in the control room, can we move the meals to where they are? Because if you look at the quantity of plastic being generated, I think we try to do the calculation, and I don't think it's sustainable. It's not friendly for the environment, and even as a business too, it's not a good thing for someone to say you're generating that volume of waste. So I saw the application of that concept. Thank you.
Fantastic. So the first thing you need to do as you go back now is to get a scale to weigh all of those wastes over a period. So you can, when you are talking about how much it is, you come in with baseline numbers. You know, one person can say, oh, we're generating a lot of waste. And next person will be like, we are not generating a lot of waste. The person who is saying we're generating a lot of waste probably talking about 10 kilos of plastic per week. And the person who says we're not generating a lot of waste probably is doing a ton per month. Right? So until you actually get to that point where you actually have weighed and you now know how much, when you are talking about whether it's much or less, it's now relative. The real weight that you have measured over time is what you're using to speak, right? So if one person has 10 kilos of weight and the next person has a ton of weight, for example, we'll go into a metric. For example, waste are generated by people. So we'll say it's 1 ton divided by 500 people, for example, right? So we'll get plastic waste per person, all right? And so we cannot compare that to the other 10 kilos. How many people are there? How many kilos per person is that pipe also generating? That's the way to use metrics to compare, okay?
All right, thank you, sir.
You're welcome. Yemisi, can you tell us what you learned from last class?
Okay. Thank you, sir. I was even waiting for you to expatiate more on this micro and micro energy.
Macro and micro.
Yes, because I'm trying to go over it and I couldn't get it very well. But with shading and the shifting of the load, then the sustainability that we thought of, I think I got that one. But that's micro and micro, it's not well understood.
Okay, macro is the big opportunities for energy saving, and micro are the small opportunities for energy savings. When I say small, it doesn't mean that overall it will be small. For example, you see this little modem I'm holding here, right?
Okay, sir.
This modem takes very little energy at the time.
Okay.
But if this modem is fully charged, if I leave it connected to power round the clock, I am not being energy efficient. And if all of us in this complex, in this campus right now, I have the same habit of leaving our modem perpetually connected, our phones perpetually connected, our laptops perpetually connected, they may all be micro energy losses, but they add up to a large energy loss overall. Whereas the macro energy losses are talking about big things like your chiller system not being efficient, your lighting, your building fabric. So the things that are more obvious, a lot of energy. Imagine putting on a big standalone 5-ton air conditioner in your living room and opening all your doors and windows. Anybody that comes into that living room will easily say, you guys are wasting energy in this place. Why can't you leave all your windows and doors open down? And this 5-ton AC is working here, right? It is obvious, it is big. From that one point, it is a huge energy loss. But in that building, you could have 20 phones, 20 laptops, and modems, and all kinds of things connected and left on. Chargers are left on every socket. Those are micro opportunities for energy saving that we should not overlook.
Okay.
All right,
All
so it's
right.
clear now, right?
Is it not the same? Sorry, sir. Is it not the same thing with load shedding and load shifting?
No, load shedding is to
Because of the
cancel certain
definition.
activities. No, load shedding means that you cancel certain activities so that they don't run. So if I decide that on break time, AC and light will go off, I'm doing load shedding. Until people come back from break, AC and light will not come on. That's load shedding. It means that I have canceled those equipment from running electricity at the time I shut them down. Any equipment that is not needed, if I shut it down, it is called load shedding.
Okay. Thank you, sir.
If you are in the office and you are leaving the office, you put off your
You
light,
off everything,
you put off your AC, you put off your water dispenser. That is load shedding. Just switching things off is called load shedding. But load shifting is that you are rescheduling that activity from a time to another time. So, for example, a washing machine, I say it should not wash in the afternoon, it should wash in the evening. I did not cancel the washing machine altogether. I just moved the time it will run from afternoon time to evening time. That is load shifting. Pumping machine, don't run during the daytime. At night when we are sleeping, pumping machine, you can run. I've moved the load from running during daytime, I've moved it to run at nighttime. That is load shifting, okay?
Thank you, sir.
You're welcome. All right, who have not spoken? Person has. Yusuf Rasak, are you in class today? And
yes,
Lawal.
I'm in class.
Yes, let's get
Hello.
Take it from the last class.
Okay. I take it from the last class is the definition of sustainability. After which we talked about energy being one of the major categories of sustainability. We talked about water. Hello.
Yeah, go
Hello.
ahead. Well, we can go ahead. You should be muted now. Unmute and continue.
Okay. Hello, can you hear me now?
Yes, we hear you.
Okay. So, like I said, we started with energy being one of the major categories of materials to be considered, one of the major categories of sustainability. Then we moved on to water. We talked about material resources, indoor environmental quality. We talked about waste. We talked about site impact, quality of services. After which we now go deeply into energy, because it is one of the major categories that need emphasis as regards sustainability. Then we talked about energy audit. We also talked about the different sources of energy. We talked about the fossil fuel, renewable energy, and the nuclear energy. I think those are some of the things I picked from the class.
Yeah, that's good enough. Thank you. Thank you, Yusuf. I'm going to go straight into this class. We have quite a lot to cover. Should I go straight or deal with? Okay, so at the end of the class, beyond the questions for this class, if you have any other work-related, career-related questions, you can also add it. So we can move the problem-solving sessions into the discussion for the end of the class, okay?
Okay.
All right, so let me share my screen. All right. I believe you all see my screen now.
Yes,
Yes.
sir, we can.
Yes, sir.
Very good. Excellent. So today we're going to be looking at FM technology. Mainly we want to look at the foundation of technology. Why do we deploy technology in facility management? What is the real business of a facility manager? Facility management, we say, should be proactive, which means we should have at the strategic level, asset lifecycle planning. We should have
this network should not start when you start this class. I mean, I can't hear you at all. Just
I'm telling you.
How about now? How about now? Is the network better now?
It's better.
It's better now.
No, okay. All right.
It's
So,
better. Let's proceed.
all right. Management is delivered at 3 key
Hello,
levels.
Sir.
Yeah.
Okay.
Francis. Francis, were you saying something?
Sir.
Yeah, were you saying something?
Hello, sir.
Yes, Francis, do you hear me?
Okay, it's better now.
We can hear you well, sir.
See what network I'm on. Let me see.
It's cracking, but I can hear you.
Okay. Let's just test this one for a few minutes and see if it's going to be better for us. My screen is still visible to everybody, right?
Yeah, very well,
Yes.
sir. Very well, sir.
Yes.
Okay.
Yes, it's
All right. So, all right, great. Thank you. Okay. So, I'm talking about the levels at which facility management is operated. We have strategic facility management, tactical FM, and operational FM. At each of these levels, the facility manager needs to understand certain focus areas so that you can apply yourself to these focus areas. And for each of the focus areas, there are certain data or information that you need to work with as a facility manager. At the strategic level, you have your asset life cycle planning, which means you decide for every asset that you have in the organization what your useful life will be, and then you create a capital replacement planning and upgrades and improvements on each of the assets over their useful life, including when they should be replaced and how much it should cost when they will be replaced in the future, right? So talking about the sinking fund thing, it's not just a matter of putting a certain amount somewhere. There is actually supposed to be a plan that covers all of the assets on your list, which has the useful life of each asset, the year or the dates they'll be due for overhaul or major upgrades, and the year or the date they will be due for replacement. The cost for that upgrade, the cost for that replacement. So if I have all of my assets in my portfolio lined out and I have dates I have useful life overhaul or improvement or upgrade, and then I have replacement dates, I need to now have amounts set aside for such large scale improvements or replacements on my asset. That's what the life cycle planning and capital replacement and improvement program entails. Beyond that, which is the normal strategic planning for your facilities, you now need to have your emergency preparedness and business continuity plan. This is where you create a risk management plan for if any of these my assets that normally should run for so number of years, for example, should fail before their due date, collapse, crash, burn, you get destroyed or get stolen, what will happen? How will I be able to cope? So this, my risk plan, is not my normal strategic plan. It's my emergency plan. It is not part of my typical capital replacement project budget or cost cash flow plan, but it is a plan for eventuality. I do all that at the strategic level. Then at the tactical level, I have a space management plan. How am I going to accommodate people into my space? How am I going to use the spaces that I have? My operations and maintenance plans, my budget for 1 year or 2 years are all part of tactical planning. And then at the operational level, I perform routine inspections, I perform operations and maintenance execution activities. In all of these levels of FM operations or FM activities, I use a lot of data, I do a lot of analysis, and I need to be able to make all of this effective or efficient or both. We'll be talking about both efficiency and effectiveness in this class. So let's get back to the basics and ask ourselves, why do we build? As property owners, developers, buyers of properties, you know, what is the real objective? We think first of the end users, the people that are going to use it. If you don't think about the people that are going to use it, whether you're going to rent it out to or you're going to sell it to, you're going to have issues because you must have value propositions for the end user. And as such, you must understand what they want to do with the spaces that you are developing. They want to live in it, they want to learn, they want to work, they want to play, they want to worship, they want to be buried in it, whatever the purpose of that end user. You need to understand what will make your facility stand out to that end user. What are the issues the end user is trying to overcome? What problems do they have? And then you think about business considerations. For example, investment returns for the organization. When an organization makes an investment in a property, they expect investment returns as well as business productivity. And you get this by, you know, you have a blend of both business returns and end users or building users well-being and productivity when you provide the proper functionality, aesthetics, well-being and safety for end users. So business will benefit when the users are productive, when they are healthy, when they have a sense of well-being, right? And then that is the way we can now say we are preserving and growing the assets on an ongoing basis. Because you've taken care of the end users, you are maintaining the assets in such a way that they will keep getting value for, you know, the services that they are paying for. And then you have the resources to continue replacing those assets for them. But often, construction projects will have 3 key objectives. They want to have a scope that is followed through as little variation as possible. They want to stay within costs. When a developer says, I'm going to build this for 10 billion, for example, he wants to see it delivered in 10 billion. Don't come telling him about an escalation or scope creep. That doesn't augur well for the project, right? And then they want to ensure that the schedule that has been agreed on, 2 years project, 1 year project, 18 months project, it is being complied with and the project is delivered as expected. Now, in all of this, there are trade-offs that usually happen okay, trade-offs that leads to feasibility analysis. Can we get it cheaply, quickly, and a good grade of scope? That's impossible. If you are going to get it, quickly, which means deliver the project at a faster speed, you will either have to spend more in costs or you will compensate by reducing your expected scope so it can be done quickly. So either way, there are so many trade-offs that take place. While these trade-offs are taking place in most of our projects, something important suffers. And that thing that suffers is called operational readiness. If you focus too much on delivering the project, you forget the real reasons why we build, which is the end users and also the asset value of the investors. So what will help you focus on the end user, focus on operational readiness, focus on sustainability of the development, focus on maintainability and all of those long-term issues that helps you to provide real value. Proper data, high quality data to meet the needs of the stakeholders who are going to use the facility. This is often lacking in many developments. All right. Sometimes data is made available, but the data is not consistent, it's not interoperable, which means the mechanical data, the architectural data, the electrical data may not be able to synchronize or be viewed seamlessly in the same platform, and accuracy will be a problem. I'm working with a team now to get a space schedule for a large complex as we speak. And what they are finding is that what we have on the drawing are very different from what we have on ground. So if I base decisions on what I see in the drawings, I'll be making a huge mistake. We have to go back and remeasure and validate the data we are seeing on drawings. Facility managers' current reality is that we scramble for information to react to facility issues. Have you ever seen yourself battling to break through walls to find out where things are buried so you can fix them? Yes, that's what basically happens. Sometimes you've broken through some walls and floors only to find out that's not where the lines were run through, and you have to start dealing with another direction because you don't have enough information. The information you have is either in drawings that are not complete, or in the heads or in the minds of a few staff that were left behind from construction. And then the architecture, engineering, and construction teams will usually send all sorts of building documentation in different formats. Some flash drives, some CDs, some paper, paper-bound folders and things like that will come to you. And then, if you have poor documentation, poor data, you will make a lot of poor management decisions. Many FMs have repaired things and spent a lot of money, things that should have been under warranty. They didn't find documentation. Many FMs have taken actions or inaction on certain things that required regulatory compliance, and they have not, and they have brought penalties to the organizations. Many have tried to repair in the absence of appropriate data, have broken and British taking the whole space just to get to the root cause of their problems. The drawings that we have will mostly be incomplete and not as built. Some organizations or developers basically just send you the original intention in design drawing as built, just relabeled or retitled and sent to you. Whereas during the design phase, up to the construction phase, to handover, a lot of changes took place that were discussed offline and online and in different forums, and documented or not documented. Those changes were built, but not documented. So when you get a drawing, you probably don't know that that drawing reflects what's on ground. You now have a job of going to ensure that you measure again and draw again as a facility manager to have your proper as-built drawings. And then the bill of quantities. It's so difficult to get bill of quantities out of certain construction team. They tend to see it as a secret document that they must keep to themselves, right? The bill of quantities and specifications is important to the FM because you need to know how to describe something when that item needs to be replaced. For example, you can look at the floor in your facility. It looks like vitrified tiles, but you cannot tell that it's vitrified tile by looking at it. It could be porcelain, it could be ceramic, it could be granite, it could be gravel, it could be marble, it could be anything. The look could be deceptive. Again, the gauge or the thickness of that tile may not be obvious by looking at it, not even by looking at the skirting on your floor tiling, right? So it's important that you get specifications of everything, and then your asset register is also key. Why are we talking about all of this? Because all of these are part of the data that form the basis for FM technology. Technology is a tool for improving efficiency and effectiveness of your FM operations. Technology is a way to do it better. Technology cannot be applied or deployed without adequate information, data, and records with which the technology can automate processes, can create prompts, can refine a way of doing things, and can make things work faster for us. Various equipment lists for contracts, incomplete equipment inventory from AEC, that's architecture, engineering, and construction. Documents come in binders by project on project, missing, binders of maintenance history, for example, and so on and so forth. The list just continues. This is our reality in the industry. The information we are looking for, we are not getting it. So where do you want to start from as facility managers? You need to have a standard way to gather data for new projects. This needs to be agreed at the onset of the project. And for old facilities, you need to have a way to reverse engineer the process. What it simply means is, I will have to go and measure and draw. Probably need a draftsman or an architect, but we need to measure what has been built. We need to develop our asset register by going to look at every asset, picking the serial numbers and model numbers and specifications and capacity from each of them one by one, and recording them in the spreadsheet or the data set that will eventually be used for us when entering into a software platform. And the reason we need accurate data is because data integration is what makes technology possible. Data integration means that the information in the asset register, the information in the as-built drawings, they should correlate. They should be, they should relate. If I put in a cost for doing a particular activity in one aspect of my facility, for example, that cost should not hang in the air as a cost on its own. That cost should connect to my asset register, and that cost should be related or linked to the asset on which I spent or invested that cost. So it's important that we have data integration. If I want to do space planning, for example, my space planning is going to start with my as-built drawing. It's from that as-built drawing, I will identify all the spaces that I can assign, designate them as assignable, and begin to assign spaces to people. When I move people from one space to another space, I literally go back to that same drawing and I relocate them and say this person is no longer in floor 1, the person is now in floor 8, and so on and so forth. So everything now needs to be connected. Even when I'm going to do a repair, my repair should be scoped. And that scoping should take me to my asset register, for example, to get the capacity description and the description of each of the equipment that I probably want to repair or maintain. That scoping can also take me to my as-built drawings. That scoping can also take me to my as-built drawings to measure the area. For example, I want to do a painting job. I should know the square meters of my walls in every space to be able to accumulate or aggregate the data for painting quantity. So that I don't just say, come and look at this space and then give me a quote for painting it. And people are saying, oh, well, we'll buy 4 buckets of paint. No, you may end up spending a lot more. If you know how many square meters of space you need to paint with this particular off-white 3040 paint, then you ask yourself, how much is 1 square meter of painting? I have 540 square meters. That will help you compare orange to apple instead of having vendors bring you different quotes in different formats or patterns. And so all of this data, they are supposed to integrate. They are supposed to link to your budgeting cycles, your capital planning, your financial management in the organization. So if you're managing a facility and you don't have data, you cannot really account for all the monies you're spending. You can't really account for the money you are getting. Well, every time you ask for money to spend on anything, for example, you cannot link that money you are asking for to particular assets, to particular spaces, to particular departments or individuals within the organization. Because that's the only way you could have added value to say, if you allow me to spend this money, I'm going to be adding value to this unit, business unit, or this department, or this individual, because I know the area they cover. It's going to bring them that and that productivity benefits. But you can't do that because the information you don't have is not enabling you to make that case. Now, in terms of technology adoption, there are 2 sides to the coin. There are the building technologies, and there is the facility management technologies. Okay, so if I were to speed forward a little bit and show you this, for example. This is BIM. Yeah, right. So I'll come to this slide to show you how you can evolve the facility management technologies. CMMS, CAFM, IWMS, and BIM. But before I get there, I need to show you how the building itself also evolves. Typically, building technology at the basic level is made up of what? Circuit breakers and fuses, switches and controllers, timers, sensors. Well, we may say sensors, but they evolve over time. So from the simple switch on, switch off to a photocell sensor that is set up outside that monitors sunlight and automatically controls a switch internally for all your security lights, for example, and does that 2 times every day. You have moved from a manual technology, which is wake up in the morning, go switch off your lights, wake up before you go to bed in the evening, switch it on for security purpose, right? That's the manual technology, switches. But the advanced technology of that is when you have to actually set up a sensor that automates that process for you. So buildings have evolved. Buildings have their own technology, all right? And so beyond those simple or single cases of switches, controllers, fuses, circuit breakers that we install to help us automate things like automatic changeovers, for example, that we install here and there, or phase reversal and things like that. We can aggregate all of this technology into a building management system. A building management system, or BMS, is a technology that helps you control an entire building. Your electrical and your mechanical systems can be controlled using a building management system. The system gets information on what is happening at every point of control, feeds that information to a central processing system or controller, where you, the facility manager manning that BMS system, can see how the operating parameters are faring, how those assets are faring. For example, you could have oxygen sensors or CO2 sensors that will sense how much oxygen there is in a certain space. It will tell you that the carbon level is too high, oxygen level must have dropped drastically, and you need to bring in fresh air. You use another controller to introduce fresh air, maybe through your central air conditioning system or through a window control system to bring in fresh air to that space. When the air is enriched sufficiently, you can then shut down that window of damper, and then the system continues to run. What we are doing is that you are getting information, you are acting on that information, you are sending signals to another controller to act in such a way that it is automatic, you are not going there, right? But that's the BMS. Now, that evolved to what we call the Building Automation System, the BAS. The Building Automation System now replaces your logic by automating it without you interfering. For example, instead of using a BMS to know that something is too cold or too hot so that I can adjust it, in a BAS system, which is a building automation system, the system is set up to automatically control itself when it reaches a certain temperature. So in essence, there will be no sending me information about it's too hot or too cold for me to adjust. The building will automatically adjust. If there's nobody in the room, for example, the building will tell itself there's nobody in the room. Switch off all lights, switch off all air conditioning. We call buildings that are deployed with building automation systems smart buildings or intelligent buildings. Logic has been written into the management system of those buildings to ensure that they can act on their own. And then, of course, all of these have advanced because there has been a lot of remote monitoring. We now have systems for viewing, getting sensors for capturing data and sending to a processing unit. And then we now have controllers that can receive information from the processing unit. So instead of that switch that used to be there, that you have to walk up to switch on and off, in a BMS system, that switch is now connected to a controller that I can control from the remote desktop. That desktop sends a signal from my BMS system to that remote controller, and that remote controller pushes the switch on or off, or moves things in the direction I want to move them. Now, in a BAS system, I am not in the picture. I have set up all the parameters in the system, and the system knows when to send information to that controller to control that switch or circuit. All right, so for us as facility managers, we just need to learn that things are moving in directions that we need to learn the systems that our modern buildings are coming with. I'll go straight. You can read up all of these items I've put here. I'll come back to the documentations. I'll go straight to the management side of things. As facility managers, we evolved from paper logbooks and paper work orders to spreadsheet like Excel, where you can aggregate information, you can analyze information, you can set up a schedule for a certain period, you can create prompts and timers inside your spreadsheet, you can assign jobs within the spreadsheet, and it makes a dashboard for you to see them. We have evolved from that to a CMMS system, which handles mainly maintenance. The CMMS system is called a computerized maintenance management system. You know, because maintenance is one of the core things we do as facility managers, the CMMS system is at the basic level, the first level of software integration in facility management. We're moving our asset register into it. We automate our maintenance program inside it. If we have a store where we have spare parts, we'll put it integrated there. If we have vendors that perform maintenance activities for us, we'll put their details there so you can assign work orders and get reports and close out jobs in that system. That's the maintenance management system that we have created. That's what the CMMS. It is a level of facility management software, like an entry level into software, where you're going to go from paper and spreadsheet into software. You start with the CMMS if you want to, right? Both planned and unplanned maintenance are handled inside the CMMS. Now, the CMMS can be a module inside a CAFM system. CAFM is computer-aided facility management system. Computer-aided facility management system. This goes beyond maintenance. CMMS is maintenance. CAFM is all of facility management. So that's what CAFM is about. What CAFM does is to introduce more modules like space planning, space allocation, space utilization analysis, visitor management, for example, who came in, who left, how long we stayed in the building, security management, energy management, all kinds of things that facility managers do, budgeting, human resources, everything comes in there in a CAFM system. So the CMMS is also a part of the CAFM system. But as you evolve in your management technology deployment, you get what we call the Integrated Work Management System, IWMS, Integrated Work Management System. It is an evolution from CAFM to an enterprise level of running your facility. It helps you integrate data capture directly into the system. In a CAFM system, for example, I will go and read a meter and take the reading and put into the system. In an IWMS system, I will integrate my BMS or BAS to be feeding data right into the system. In essence, all my meters will report in here. My water flow meters, my electricity flow meter, my diesel run time and diesel consumption, they'll report in here. I will no longer have to go around reading and observing them and taking data into the system the way I did the CAFM system. I'll integrate my CCTV, for example, so I can do space utilization and space use analysis, straight from my IWMS. I can integrate my budgeting and my expenditure directly to accounts and finance and procurement, so that all of those RFPs and RFQs can be automated in the system using an IWMS system. And if an organization has an ERP system, Enterprise Resource Planning tool, for example, SAP or Sage 1, an IWMS system in the FM department can directly connect with that system in the entire organization. This is the evolution of software within the FM management space. CMMS, CAFM, IWMS. BIM for facility management is an approach that utilizes building information modeling as a source of information. Information is a compilation of assets and parameters of objects from the design through construction to operation of the facility. The BIM approach is an advancement to the more traditional approach. What a BIM system does is, instead of having to gather all of those data that I'll be putting into a CMMS CAFM or IWMS system, I will use BIM as a 3D model that aggregates both visual and documentary data into a digital twin and into a folder structure right from design. And as changes are taking place in the building, I'm visualizing, editing, auditing, replacing data within the system. And there's a historical track record of how data is acquired and audited throughout the building life cycle. So by the time I'm doing facility management, what BIM has done is that every decision taken, every step, every material brought in, every work process, every document generated are all in a central place. That's what building information modeling does. So to give you an idea of how this data works, I will go back to this where you have the list of minimum required documentation as build drawings. In fact, by the time you have your BIM model, it's as good as having a three-dimensional as-built drawing. You can see everything the way they are. The asset register, the basic quantities, the snacks and defect list, the construction team and vendor details, equipment guarantees and warranties, manufacturer's operation and maintenance manuals, regulatory permits and other legal documentation, testing and commissioning, building systems and equipment specifications, equipment components and parts lists and recommended spare parts, and so on and so forth. These are information that you need as a facility manager to run the facility. So if you don't have a software, you need to refer to them, get information, and take decisions based on the information you are getting from them. But if you do have a software, there must be a way to impute all of this data into the software. Whether it is for CMMS system, for example, you need to put in your asset register and then your equipment parts list from this. For CAPM system or another BMS system, all of this gets to go into your technology platform. The whole idea is that information is available for decision making as at when due. And if you automate your building processes to the point where your building now makes decisions on its own, then of course you have the data to automate that process. So we said a CMMS is computerized maintenance management system. It's asset, schedule and track maintenance tasks, keep a historical record of the work they perform, maintain a computer database of information on maintenance operation. If you are fixing, repairing, maintaining, and you're not using a computerized system, it will be possible for you to be doing the same thing again and again, making the same mistake over and over again, because you don't have a system for tracking the trends that you are experiencing in that facility. Okay, so whether you're deploying a CMMS, a CAPM system, or an IWMS system, it depends on your technology maturity within the organization. Not all organization or not all scope of work will require the deployment of the software. Some scope of work is too small that having a software to run it would simply mean an inefficient use of the software, right? So you need to go through a process of understanding how much work you need to get done, your level of technology within the organization, how much management will respond to deployment of technology, and then you go through the process of getting their buy-in, define your requirements and goals. You gather a list of the data that needs to go into the software need to already exist. You cannot begin to deploy a software for facility management when you don't already have the baseline data. You're not already working with spreadsheets and data in terms of work processes. deploying a software will not make sense. You transfer what you are doing manually into a software. It's a garbage in, garbage out scenario. The CAFM, just like the CMMS, it helps you improve efficiency and effectiveness, but it does a lot more. And I've explained this before. Beyond maintenance, it helps you track and report operations, space management and space moves. Anything you can imagine you do as a facility manager comes in here. On the point of the benefits of deploying any of the software, whether CAFM, CMMS, it's important to know the difference between efficiency and effectiveness. Efficiency points to how quickly you get things done and how cheaply you get things done. It costs and time, but efficiency tracks. It's more of speed of execution. But effectiveness is more strategic. It's more about, are you achieving your goals? Are you achieving your strategic objectives? It's more about direction than speed. And that's why we say technology should aid or enhance both efficiency, which is getting things done quickly and cheaply, and effectiveness, which is getting your goals achieved. You could be running very fast. That's efficiency. You can be running with the least amount of energy. That is efficiency. But where are you going? Running very fast with the least amount of energy in the wrong direction, you are not being effective. Effectiveness means that you are hitting your mark, you are hitting your goal, and you are moving in the right direction. And that's one of, and those are both things you could get from deploying software. So whether it's a CAFM or CMMS, the benefits will most likely be the same. But every time you want to deploy software, you sometimes have issues. And I think the biggest issue is the fact that many of us don't even have the data with which to implement the software. Many software deployments fail because we don't have the right data and the right processes before we went into it. But beyond that, budgets, because technology will require costs, can be an issue. People to run this system, the resources might be an issue. You want to deploy the software, everybody again, you yourself have to improve in how to manage a software system, and you have to have a way of managing change in the organization. Political priorities. It may not be a priority. Management might say, oh, well, we are doing fine right now. Why do you want to go and deploy software? You want to make your life easier for yourself, or you don't want to do work anymore. And sometimes it could be a case of unfunded mandates. Management says, oh yes, we can deploy technology, but we don't have funding for it. And then data, big issue. And the stovepipes refers to situations where different departments are deploying different technologies that are based on different platforms, and they cannot integrate data. Procurements will not be able to connect to FM software nor connect to finance and account software so that it can run seamlessly. That's a big issue for software deployment. So when you as an FM is trying to bring up a software that you think you need for your services in facility management, what other departments are using in terms of technology platforms, so that you can see whether yours can integrate. If you cannot integrate, it's not worth it. All right, I'm going to take this last item on BIM, and then we'll have a little break. What is BIM? An intelligent 3D model-based process that equips building professionals with the insight and tools to efficiently plan, design, construct, and manage buildings and infrastructure from cradle to grave. the generation and management of digital representations of physical and functional characteristics of places. Files which can be exchanged on network to support decision-making about a place. A digital representation of physical and functional characteristics of the facility. A shared knowledge resource for information about the facility, forming a reliable basis for decisions during its life cycle. If you deploy BIM from the design at handover, there is nothing much to hand over. You see that list of documents we are looking for, they're already built into the BIM database. I have all the information I need about this facility. I wouldn't need to start searching for papers, searching for different formats of documents, because all of those documents are embedded into the model. I just put my cursor around it and I see information about the slab, information about the roof, information about the wall, information about everything concerning the building. It's a very important tool, which is been largely under-deployed, underutilized, underused in Nigeria and in Africa generally. People are building and construction sites are wasting close to 30% of their construction costs on disjointed information management, people working in different formats, time waste, resource planning not being efficient, all kinds of estimation errors are coming out of construction today because we're not deploying BIM. A lot of times we do some work, we find an error and we have to redo it again because we're not deploying BIM. Sometimes we have lengthy periods of time between requests for approval and actually getting approval because we are sending information from format to format for people to look at and give us feedback. If all of us work in the same platform, work in the same model, we will exchange information real time. I'll be seeing what you are doing, you'll be seeing what I'm doing. Imagine an architect creating a floor slab, the mechanical engineer putting in pipes that are going to be buried into that floor slab at the same time as the floor slab is being created by the architect. And the guy is testing the structural integrity of the building, looking at how the piping network is going to flow inside that slab and how it's going to affect the strength of the slab, and deciding what additional reinforcement to put in certain areas because he's seeing that flow of activity. An electrical engineer doing his designs and seeing how cables are going to run from one end to the other, from one point of use or load point to the distribution point or consumer unit point. He's seeing the distance and prescribing the right kind of cable because of how much distance that current is going to run through from the source to its use point. All of that information is clear, transparent to all parties. If I'm going to make a change to my slab, for example, oh, I want to reduce my cost of concrete. I'm going to reduce my slab from 6 inches to 4.5 inches, for example. The guy fixing the pipe is going to see that certain pipes are 4 inches or 5 inches and will be exposed, or that there will be no concrete cover for that area where the pipe is going through, because we're all working in the same platform. Not to design separately and start reading different types of drawings, trying to coordinate them by looking at different drawings is what is happening in construction site today. So a lot of waste because they're not deploying BIM as a technology. And so the benefits include reduced cost and time needed to collect and build your CMMS data, your CAFM data, your BMS or BAS systems. Improve data quality in FM systems, of course. Paper files are not required anymore. Reduce cost and time needed to address equipment problems. Use of the greatest system to plan building modification. And better building and equipment performance. Of course, your equipment to be better off if you have BIM deployed. We'll talk about the BMS, standalone application that controls buildings, especially mechanical, electrical services in the building. And then we talked about how the BMS can become advanced to become a BAS system, which is a building automation system, a system that automatically controls itself, okay, as an intelligent building. And these can bring all kinds of benefits, reduces environmental impact, improves security, building maintenance, operator convenience, real-time status update, constant access, and so on and so forth. BAS can set up your lighting and HVAC system to operate on a schedule. Those systems can become more intelligent and efficient. They can decide to increase or reduce according to occupancy, for example. You get the various components and facilities within the building to coordinate and work together. So you can see a light can speak to the AC. If a light has observed that there's nobody in space and it's about to go off, you can also tell the AC there's nobody in this space. Do you mind going off as well? That's what a smart building does, okay? And if there's an emergency, the information goes faster because there is all the systems in the building are interconnected, and you discover problems faster and make things more efficient. I'm going to take a break now, and then when we come back, we're going to look at management technology, various technologies that we can, investigate further, deploy within our facility management spaces, mostly in the building technologies. Lots and lots of technologies we'll be reviewing as we come back. Thank you.
We did our short pass. Hello, I can't hear anything again. I lost volume.
We're on break.
We're still on break.
Okay. Hello. Hello.
Still on break. Still on
We're on break.
Okay. I guess we've done 5 minutes already. Am I mistaken?
No.
Okay. So let's start with a basic functionality of facility management, asset registers. You know, at the basic level, manually, you're supposed to have a count of all your assets. With that count, you have certain descriptions, parameters, specifications of that asset, so that you can have full accountability for the asset. That is basic facility management, right? Now, if you have a vast array or amount or quantity of assets, and you have a lot of data, I've seen some asset registers that are millions of rows. If that is the case, and you now want to deploy technology, your technology can now go beyond the manual, where you are no longer just writing the asset ID or tag on the body of the assets to reflect that ID in the spreadsheet. You can now use a tag that could be barcode, that could be RFID, which is radio frequency identification tags, or QR, quick reference codes, that will now be an interface between the information that you populate about the assets inside the software and what people see. So you're no longer looking at the assets and saying this is asset number 25. you are seeing the asset as asset number 25, but all the information about that asset can be clicked through to be accessed through that tag. I can click into the assets, maybe an air conditioner, for example, that I'm just finished servicing. I click on it. I see the information of the asset, including the last time it was serviced, what kind of repairs were done on it. As I finish doing my own servicing, I update it to say I did it and did that. That information goes in. If there's a cost to it, it's entered in there. If there's a customer complaint related to it, it's entered in there. Every information about that asset is there. So anybody that has access to the data, we simply have an app with which you will click or just scan and access that data. If you're trying to make a case for a replacement and say, oh, this asset has been failing so for very often, for example, you will not be going to look for work orders to count how many times the work order generated by that asset. All you just basically do is scan it, pull up the data on that asset, and then have all of that information aggregated for you. All the spare parts that have been replaced, they will be there. All the hours that have been spent working on that asset will be there. All costs spent will be there. In fact, some of these tags can even be GIS enabled, position enabled, such that if an asset is moved from one aspect of a facility to the other aspect of a facility, the system gets a trigger that that asset has left its location. So assets that need to be placed in a particular location are tagged with that location as part of the tagging. This is a technology that helps you leapfrog your FM operations to a very advanced level. So you're no longer having an asset register that is more like a dummy tool you look at and update all the time. It now becomes a working tool. Your maintenance can be done into the system. It's integrated into your CMMS, integrated into every information you have about your assets or spaces. If I move people from this room to another room and bring another people into this room information is updated because this room itself has its own asset tag. There is a leak detection and speedy repairs based on data analysis from sensors. You could actually have leak detection sensors. This is a technology that has been around for more than 5 years, but it's not being rapidly deployed because we don't see leaks as a big problem. First, you don't consider water as very expensive, so your water leaks can be a loss that is not so significant. But if you manage a facility that water leak can cause maximum damage to the building fabric and what is stored in that facility, I am sure you will take leak detection and speedy repairs as a big deal. What these systems do is monitor pressure changes and also monitor humidity levels within service lanes where your piping goes through. So you can know when something is leaking as quickly as possible. It sends signals back to you in your phone or your laptop. We know right now without anybody even seeing water that system is failing or leaking. Intelligent waste management system, waste collection system. This is very interesting. You know, if you have to go around to every receptacle at certain points of the day to check if there's waste to take out, you will do all that round. You have enough people doing that continuously. What if you can have a system where you have sensors on each of those receptacles? All the refuse bins have a sensor that gives you an indication of the volume of refuse in them. Would that not make your work easier? Would that not make you employ less people just going around to check? Would that not reduce the level of intrusion as facility managers will do in spaces? It's every time you want to do your FM very well, we say proactive FM, you want to go and check. You know, sometimes your appearance all the time, you and your team showing up to check this and check that can be a nuisance in your facility. What if you have a system for telling you that that floor and that room is a space where you have refuse that you can remove? No need to make all the rounds. Just go straight to the areas where there's enough refuse. Would that be fantastic as a technology deployed? You also have adjustment to energy demand by household appliances in relation to dynamic energy pricing. This may not be relevant to us yet because our energy grid is not yet a smart grid. So our consumption is the same, is built the same way, daytime and nighttime. If you're in Europe, for example, in the US, there are certain distribution companies that provides electricity with using different rates, right? They use different rates. So if they want to encourage people to move, because you know generation plants, they will produce at constant capacity, but at the demand end, capacity fluctuates. But generation plants will have to be sized to the peak, because you cannot be adding modules and removing modules at such a huge frequency. So you have investments in generation modules, in generation capacity. So what they try to do to balance so that the demand end can be smoothing out as much as possible is to have different rates. Imagine in Nigeria today, if we have daytime electricity rate of 50 naira per kilowatt hour, and nighttime of 10 naira per kilowatt hour. You can imagine how many people will stay up at night to do their laundry, for example. People that will set their fridges and freezers to automatically go off in the morning and come on at night, for example, right? There are automatic systems that have been developed in such to adjust energy demand by household appliances in reaction to dynamic energy pricing. And then this next one is the holy grail when it comes to energy efficiency. Circuit level energy monitoring, real-time insights. We are used to metering, aggregate metering, total for the building, total for the site, even sub-metering per floor, per wing, for example. Have you considered metering at every circuit level, metering every socket, metering every light circuit? You know what that will do for you? It will give you direct information, real time, round the clock, on what's on and what is off, and what every circuit consumes. I might be in this workstation, like every other person in different workstations in the building. You, as facility manager, may not know that I probably have a gadget, maybe a device, a gaming device that draws a lot of energy, or a Bitcoin mining rig under my desk, on top of my desk that I'm using. Or my coffee machine is a very sophisticated one. Whenever I plug it in, it draws in a lot of energy because you need to process gourmet coffee beans into coffee drink for me, right? All of those will not be shown by your aggregate metering or your sub-metering. But if I have metered that particular circuit, that socket where your connections are plugged in, I can create a comparison. Why does everyone else use between 1 kilowatt to 3 kilowatts per day, and this guy consistently or persistently uses 35 kilowatt hours? Because I can tell I can tell this is this person's consumption. This is this person's use because I've metered. And I showed you a device that we use for that in the last class, a device that can be connected to a distribution board or a panel, not to measure only what comes in and out of that panel, but to measure every circuit, every fuse or breaker in that panel, all labeled according to their device names or assets or equipment or space names. There are technologies for reducing congestion in the use of transportation infrastructure, such as roads and parking spaces. A case in point in this is when you have commercial parking or large office complex parking, and you are trying to drive into a parking lot, you need to have information as to which floors has free spaces. This technology is very simple. What they basically do is have sensors on every space. That sensor observes and notices the presence of an object as big as a vehicle and counts that space as used. So when I'm coming in, I can see that these spaces have been used. And if I have multiple lanes that I can take to approach the parking lots, for example, I already know the lanes to choose and reduce congestion because I know where there's vacant space. If there are none, I can just move off instead of wasting my time. Real-time access to sensor and surveillance video data for proactive occupant safety efforts. When you have CCTV, and the CCTV is installed in such a way that you have a display array where monitoring is taking place of the activity. In fact, those monitoring now have AI, artificial intelligence, built into them to pick up certain rapid motions as an escalation and trigger an alarm so that the individual security team watching will pay attention to a particular space if there are certain types of motion, maybe multiple fast-paced activities can be picked up for attention. And in some areas, even lights can be made to come up to brighten and beam in a certain space. And for some, recording may not be going on around the clock until there's an activity trigger. Recording starts, lights come on. Even an audio mic can be activated on such activity to pick audio from such systems. And then you have data-driven decision-making at all levels of management that results in effective solutions to problems. The more data you acquire, the better decisions you can make. We talked about sustainability a few days ago, a couple of days ago. Without data, you cannot implement sustainability. Without data, you cannot be writing your budgeting. Without data, there's no technology you can deploy that will make sense. And then technologies like smartphones, tablets, laptops can be used to control lights, cooling, and everyday appliances. You must have heard of some of those smart homes. What is a smart home? It's just a series of controllers connected to the various switches in the building. Those controllers have a communication with the internet. That communication with the internet has a software interface that you can have an application installed in your phone or your laptop that you can use to communicate with those systems. So you can see through a camera, a CCTV camera with your phone or device. You can access and directly control or even speak to people around your building through a speaker, through the mic on your phone and that app. You can beam lights, you can put off things. You can heat up water and switch on and off devices in your facilities just by that application. For some, you have it as a smart distribution board where all your circuits are connected and they're all labeled in there. And in your phone, you can decide, switch off the light in that room, switch off the sockets that TV is connected to, and so on and so forth. Appliances are now equipped with sensors to monitor the condition of the appliance for predictive maintenance. The equipment itself now has enough sensors. I mean, with vehicles and generators, we already experienced this. Temperature is going up, you now know. Vibration is becoming too much, you now know. There are certain subtle changes to operating parameters that you may not observe, but the sensors will pick them up. They will present it in such a way that this is within range and this is outside range of normal operation. And then there are CCTVs that are now being used for security. They can use for access management, where everybody that should access a certain space have been captured, their image, and probably their eyes have been scanned into the system. So you don't even need to use cards and and keys anymore. You can just walk through because the system identifies you. And if an intruder or a wrong person that's not been configured into that system tries to go through the system, there will be a resistance. The system or the building itself will resist it. Internet of Things, IoT networks with intelligent information and feedback by monitoring routine habits of occupants. Now, this is one area where the evolution is so fast these days. If I go to the shop all the time and I buy a certain set of items and I put them in my fridge can be made to become so intelligent that it knows exactly what I get. It knows how frequently I use them and how long it takes me to consume them, and can become intelligent enough to create prompts for me to refill them. And if I have an ordering system with, say, a shop or a mall, for example, they can actually be getting information directly from my refrigerator or my store. Internet of Things applications can be used for all kinds of things. The whole idea here is that every time you install a sensor that is directly connected to the internet through GPRS, GSM, or LoRa network, any of those networks that can help send that data real time into the internet for actions to be taken by the software application or by other people. That's what Internet of Things is, where gadgets now speak to each other. Computer speaking to laptop is simple, right? But your toner, your lap inside your printer, being able to compartment reorder form, for example. That's what we're talking about. The toner is finishing, it knows how much is left in the store, and it knows when to set up a reorder. And then for our landscaping, even farming now has huge budget. There are systems for monitoring moisture level in the soil. Instead of just watering and wasting, the soil itself can send signals to say, this is how wet I am, this is how much wetness this plant around me requires. So if you have different plants around your facility, for example, not all of them require the same amount of water. You program sensors around each type of plant, so the sensors tell you if the soil has enough water that will meet that plant requirement. If it's not, it triggers the irrigation system to water that area to the level it requires. Imagine how much water will be saved just from this system. Street lighting. You can reduce energy consumption of street lights and improve safety by just making the lights respond to activity. Instead of having lights on around the clock in the night, the lights could dim, could go off in some areas, come on based on activity. And then robots and drones, surveys, infrastructure management. I told you some time ago about glass panels falling from a high-rise building, for example. Those glass panels might have been difficult to assess, to inspect as a facility manager. Using robots and drones, especially drones these days, they carry cameras, they carry all kinds of things that can go and inspect for you. You can look at your rooftop and bring information down to you, especially when you're doing high-rise facility management. Big data analysis determines the most likely cause of asset failures for improved reliability. Even the various data you gather across your facility need to be interpreted. So big data is a function or a technology for aggregating data from multiple sources and making sense out of it. Predictive maintenance, data analysis combined with techniques like real-time condition monitoring to maintain asset integrity. Assets can now be run using predictive maintenance because of all the data that can be collected. And if there's going to be a fault or a failure, that is predicted based on the data that's been analyzed. And then for emergencies, apps that can send alerts in case of emergency, report incidents, and automatically detect locations of issues are also in play as well. All right, moving on. Smart grid and smart energy systems. Energy generation, energy distribution, energy transmission, energy consumption, monitoring of peaks, and ensuring that energy is not wasted. That's possible if we have a smart metering system. Start with the grid has to be integrated with our meters, integrated with other sources. And then microgrid distributed generation with renewable sources, bidirectional intelligent grids for transmission and distribution network. Now, we may not be experiencing this here at this time, but I'm not sure it's going to take another few years to get into this smart grid business. You know that you buy electricity using your meter. Your meter right now is one way. It takes power from the national grid or from your whatever source, and then it feeds it into your facility. Now you, as a facility manager or homeowner, also develop other energy sources, right? And every now and then, for example, your solar panels will generate electricity, and they may generate electricity that is too much that you may not need at that time. With a bidirectional smart metering, your power can actually be fed back into the grid so that the grid can use it elsewhere. And then you can take it back again. So there'll be a netting off process back and forth for whoever is generating. And that can allow multiple generators across the country be integrated into the grid in such a way that whoever is generating, it doesn't matter, use all you need, and what you don't need goes back into the system. We talked about water, smart water solutions that minimizes waste and security and secure quality as part of our sustainability efforts, leakage detection, water pollution prevention with sensors that can measure the quality of water in real time. Right now, we are taking samples to the lab every now and then, but there are sensors that can be installed with it to monitor the various impurities inside the water that's running through your pipes. Intelligent flood warning can use predictive analytics on weather forecast data combined with geographical data to forecast probable flooding zones sometimes. Imagine being able to know when your area is going to flood and when your building is going to flood. predictive maintenance on water infrastructure is achieved with sensors in the pipes that measure flow, pressure, and acoustic signals. So in essence, technology is all about data, ladies and gentlemen, all right? Data, data, data. You cannot have any technology that does not depend on data. Quality of data matters a lot, okay? And with all of that data comes the risk of data intrusion. I know a lot of facilities where the owner says, no, don't deploy technology for me, I'll deploy myself. I have to have full control. I don't want my data to be used here and there. I don't want sensors connected to me. I don't have control over the IPs or servers where those sensors will be connected to, right? Or I don't want passwords issued to external people to access my facility remotely, and so on and so forth. We must understand the risk of having all of this data and all of these controls, and to understand them is easy for us to get and get deploying technology. But we cannot say about deploying technology when we are not yet at the point where we have baseline facility management data. We don't have metrics. We don't have things we are measuring. You can't measure, you cannot manage what you cannot measure. And you cannot improve what you cannot measure. Since technology is a tool for improvement, you have to have measurements in place. You have to have data in place before you can now begin to deploy technology to improve it. Because in any case, if you deploy technology, how do you know what gains that technology has brought about? It's easy to estimate how much it's going to cost, but how do you estimate how much gain you're going to make from that technology? Many IT initiatives fail due to poor planning and execution. Select your team, people who must be passionate about quality improvement, committed to open communication, well-respected in the organization. They understand the benefits of FM technology and have decision-making ability. They have some power or authority within the organization, and they can collaborate and work together. Even beyond that, you must ask yourself why all the time. Why should we, deploy this technology? Not just because others are deploying it. Okay. How do you get to choose software? How do you know what's available? There are multiple opportunities. Search the internet, attend forum and discussions, talk with others, talk with vendors, get to hear from them. Of course, they will all tell you that their software is the best for you. Get a consultant, an integrator, an FM integrator to work with you on your software deployment, because most of the times you have failed with software deployment is because you didn't have someone who can work with you on refining your processes and make sure documentation and data is intact before you go ahead and deploy or buy the software. So just take the little steps towards technology deployment. Ensure that when you have technology in place, you get people to use it, and as people start using it, celebrate, their success and follow up with them on a regular basis. And not just the vendors who's coming to deploy it. Those vendors must also have that direct engagement with the users so that all problems can be resolved. There's a lot of hand-holding that goes on during software deployment. If it's not carefully followed, you will have all kinds of issues. Finally, some of the issues that you should avoid: don't have unrealistic expectations. Set the proper expectations. Big outcomes for the software deployment must be clear in everybody's mind. Sometimes some people deploy technology or have members in the team who are not committed. Sometimes we just go ahead thinking that the contractor or the FM or the technology provider will have all the information for us, right? Or do everything for us. No, we need to plan with them carefully. Quality and all the quality measures to ensure that it's done well needs to be taken on board. Communication is a big deal. Don't have anything in your head that's not been communicated to others. Let people understand, be on the same page. And then as an FM, if you don't have enough authority to deploy software, you find out that people above you might be undercutting your efforts by bypassing the technology at the least point of resistance, and you may not end up getting any result out of it. So this is a small economic example of a software deployment that you can take a look at. The whole idea here is to be able to estimate how much the software is going to cost you, how savings you're going to get on an ongoing basis from year to year as you deploy the software. All right, so I'll take your questions and we'll have a discussion now. Let's have a 5 minutes break and then I'll take your questions.
I really appreciate the lecture. Today's lecture was quite insightful and interesting. I just want you to clarify more on BMS and BAS, okay. Building Management System and Building Automation System.
Okay, that's good. All right, I'll do that. Building Management System and Building Automation System both use sensors and controllers. What do I mean? You have air conditioning system, for example. The air conditioning system has a control mechanism. You can power them on, you can power them off, you can regulate temperature. If it's the one that allows oxygen in, you can go open certain dampers and oxygen, air will be allowed, fresh air will be allowed in, and so on and so forth. That's a normal manual operation. Now, but in a building management system, I now have sensors attached to the controllers and sensors attached to the equipment itself. Those sensors will bring information to me in a central system. Usually a building management system is installed on the building, on the premises. There's usually a mainframe computer that is connected to all of those sensors. So the one attached to the equipment or assets is bringing information on the operating parameters, okay? Telling the main processor that there's this frequency here, there's this temperature there, there's this CO2 there, there's this and there's that, right? So all of those are happening and the information is coming in through that sensor. It could be wired to the mainframe system. Most BMS systems that were installed, before, in fact, most BMS systems are wired in. So there's a communication port where the computer is connected to. That communication port is connected to a central, like a server, and that server is connected to all of those equipment that's monitoring, right? Now, as the information comes from the equipment to the main computer, the computer analyzes and tells the operator certain information that the operator needs to work with. For example, something is overheating, something is working too slow, something is not right. The operator uses that information to create a work order to go and fix those things. If it is temperature control, for example, the operator will know that a certain space is too cold because there's a sensor that reads ambient temperature in that space and sends that information in. If that space is too cold, the operator will not decide to control the air conditioning in that space to raise the temperature a little bit to the comfortable temperature. Now, that control for a BMS system can be done automatically on the laptop. For example, on the computer, I can do a control of that temperature for the chiller water to not be so cold. I can do a control to switch off certain things from here. But there are some things that will be uncontrollable from here because it's a fault that the sensor has brought back. I'll have to actually get people to go and do a job on it. For example, a certain motor that is supposed to come on and pump water or pump air is not working. The system cannot be controlled to keep it on because power is getting to it, but it is not moving. In that case, I'll have to go and repair it before I can control it to start working. That is a BMS system, which means there is automation, there is data and sensors, there is control, but that control is being operated. Now, if I have the same system where I don't need to operate, certain logic has been written into the system to make it act in certain way on its own. That is a building automation system. That's called a BAS system. So it's an upgrade on a BMS system. What that simply means is that the system can run itself. It will come on when it should come on. It will regulate its temperature because it's been told don't go below 23 degrees Celsius, for example. It will regulate light intensity. It will remove light when there's nobody. It will all kinds of things you have built into it in terms of smart logic. It will run them on its own. That's a BAS system. That's why those buildings are called intelligent buildings, and that's why they are very few. There are hundreds, if not thousands, of buildings with BMS systems in Nigeria today, but they are not intelligent buildings, they are not smart buildings, they are not energy-rated buildings. But the very few that have BAS systems are smart buildings, they're intelligent buildings, and they can easily become energy-rated for energy efficiency.
Thank you very much, sir.
You're welcome. Emmanuel E., can we hear from you, please?
Good evening, class. Good evening, sir.
Good evening, welcome.
Question, can you hear me, sir?
Yes.
Hello.
Clear.
Okay,
we hear you
so
clear.
Okay, so my question is, first of all, the input to FM. Can you hear me, sir?
Yes, please come again.
Okay, input to the input informations. That's FMIS from construction, the as-built join, the comprehensive facility.
Yes. Yes. What's the question about that?
Yes, or a CAFM. So what my question is, are you saying that if I do not have this information, I can't use the software? I can't even begin to use the software in my facility, that all this information must be available for me to use such this softwares? Or is it possible to have probably just one? Because I'm looking at the building, I'm looking at a facility where this information are not available, and you actually do want to start using such software. So is it necessary to have all this information? That's why I'm asking that question.
Okay, not necessarily all. The relevant ones for the functionality you want to create. For example, if I want to use the space planning module, for example, I must have as-built drawings, right? If I want to do maintenance,
okay,
I must have asset register. I must have warrants, all the descriptions of all the various assets. I must have the operations and maintenance manuals of each of those assets. I must have, you understand? So without those information, I cannot do it well. I might just be struggling, garbage in, garbage out kind of thing, but I need information to use that module correctly. If I want to do access control and security, for example, I must have a database of all the occupants in the facility. I must have the various types of contracts that exist between us and them. I must have the various spaces where they occupy so that their level of access will be established, and so on and so forth. So the whole idea is, it's not about having everything, it's about having the relevant information to improve that particular function that you want to institute using the software. So you find that some people have software that can do 20 things, but they're only using it for one thing.
Okay.
You understand? I see many FMs that they use the software for only reporting failures. My door is broken. my water is not running. This place, the AC is gone bad, right? That's all they are doing. The least that software will require as information is your space hierarchy, so that each person can be able to scroll down and pick his room number and say, I am in room 205, floor this in building that, right? And in this building, the AC number 1 is not working, isn't it? Right. So because there must be some information that will make you use even that simple work order functionality. And as simple as that work order functionality is, if you don't have the asset of your vendors, if you have data of your vendors, it may be impossible. It means that the request will come in and you cannot use the same system to assign that work to a vendor or to a staff because you don't have the data of those staff or vendors in the system. Or if you have a spare parts in store, are you going to use paper, print the work order out of the system that the individual has put there, and then go to store and use paper to sign for materials? You get what I'm saying? So you have to have an inventory database of your spare parts embedded inside, so that real time you can tell this particular part is available, it's not available, and so on and so forth. So it's about relevant data. And that's why you need a consultant when deploying the software. Because sometimes you may think that, and the truth is, if you tell the software providers, we don't have any data, we just have only this small rickety data, they will just put it inside for you like that. They want to sell. So, but the consultants will walk you through the process of acquiring, refining that data to the level where at least some of the functionalities that are critical to your success, you will get to work with that software. Okay.
Okay. So thank you. You really answered the question I was aiming for. So I could actually just focus on one particular thing instead of focusing on everything. Okay, thank you very much on that.
Exactly.
Okay, so my second question is this. We've spoken a lot about the softwares. So is there any part of it, are we going to have any training and physical on-hand training in terms of this software, how to use them or not? And if we are not going to be doing that in this training, could you direct us to the most basic one and where to get that training from?
Okay, so the thing about software is every manufacturer, every designer, every software developer provides training for their software.
Oh, okay.
Now, they provide training for their software. There is no facility software training that you can go and say, let's take this training, right? But because they will all deal with your asset module, your maintenance module, your space planning module, your vendor management module, and so on and so forth, there's a way you can learn one software and relate with other softwares when you are going to use any other software easily. As part of this course, there is a day for learning how to use. We have a software provider that will come in and provide training on the Instanta software. It's a made in Nigeria facility software. And we'll have a session to take that with you guys. That will give you basic exposure to the software.
Okay, thank you for that. Thank you very much.
All right.
Thank you for that, sir.
Put down your hand. You're welcome. Yeah, your hand was up.
I really appreciate this feedback that we are going to have that medium, sir. It's really...
Yes, you definitely have that session, a full 3 hours of software demo. Okay.
All right. Good afternoon. I don't know if I'm being
please go ahead. You are being heard, but I thought you were going to speak. Go ahead now.
Okay, I have having challenges with the network today. Okay, I think basically I'm thinking for now the only aspect in terms of automation that I have in our FM system is the fire protection system, because we have the automatic. That is, for me, it seems to be like a standalone system. Linked to per se. So I don't know. Is it like the using management system in the future, for example?
Do you have a BMS installed? Yeah, I didn't quite get your question.
Okay, what I'm asking, for now, we have the automatic FM 200 fire suppression system, which is installed.
Is it for the whole facility or for a certain area?
No, for the server room for now.
Yes, good.
Okay, but for me, that looks like a standalone system. And how can one integrate it? We have an enterprise resource software, which we use for work order, for requisitions and job orders, maintenance requests. So is it possible to integrate like that fire suppression system to this system we use for the job orders and the rest of them?
For you have to set up a building management system or building automation system before you will be able to. So that's where you integrate individual equipment into. The data from individual equipment goes into a BMS or BAS system, and then the data from the BMS or BAS system can feed into your either BMS or enterprise resource planning tool, because all of the data from individual equipment cannot come into an enterprise resource planning tool directly. They have to be aggregated because you have to have certain analysis done at the BMS level that will tell you whether to generate a work order. For example, an automatic work order, a job assignment, or anything will come out of that operating data that's getting from the equipment. So it's not directly to the enterprise resource planning tool, but to a building management system first.
Okay.
Because
that is
the HVAC
Thank
system
you.
will be connected there, yes. Your lighting system will be connected there, your FM tunnel will be connected there. All of those things can send information into your building system. And that's from where it can now be linked to feed data, if it can be, if it has portability of data. Perfect.
Okay.
Africa, we go ahead. Good evening.
Yes, thanks so much for the lecture. I really appreciate this particular lecture because it's a way more exposing to technology. Because this thing obviously, I was in one of our facility here yesterday in our toilet. So I detected that when I entered, somebody that used the toilet previously didn't flush well. So I was not thinking in my mind that there should be a device like if you don't flush, the door should not open. So I was thinking like, how do we control it? Because even here in our facility, some people, the people who work at the technical department, they are like a way off because every 2 months we are trying to unblock a blocked toilet
yeah.
Because when they finish using their rags, instead of them to use the bubble washer, they just use the rag and throw it inside the WC and flush with it. So I was like, anytime this kind of a thing happens, it's like the door should not open. I was thinking there's nothing we can do because and we can't put CCTV. They can't put CCTV in the toilet. So yeah, because it's against the policy. So I was that there's nothing we can do anytime we have such issues. We just fix it. We just go there and land, but that doesn't mean they will still repeat it. They will. So I was not thinking there should be a device that anytime you are flushing a foreign object inside the WC, the door should be blocked until you correct it. But with the course today, I really learned a lot about this, particularly about this leaking stuff. When there is leakage, there's something that we alert you that there is leakage at this place. It will save stress from running from one floor to another, just inside of this kind of particular thing. And even some people like with these things have been happening since 3 days ago. You have not fixed it. So somebody will have to know that this is actually like that this thing just started today. So much like that. And that now referred me to a seminar I attended, the future of works relating to technology. That some people will be at fear that as technology is advancing now, this much thing people are doing manually before is being done automated. There will be like a fear for some people that won't they lose their job, won't they lose this, So the symposium was able to communicate to everybody that we will not lose your job because as technology is advancing, it's creating another more jobs. You just have to update yourself. When the thing you've done manually, when it's being automated, go and learn how to maybe to operate a machine to control this, or how to monitor a machine to control that. I really enjoy this particular course. I must say. Good. So, but my question is, in slide 15, you were trying to explain this technology where it's talking about the IWS, remote monitoring. Please, can you just go back and just summarize this remote controlling IWS, BIMS, and BA, because the network was breaking when you were delivering the lecture as regards that slide 15.
I'm actually sharing my screen.
No, you are not sharing your screen. Slide 15.
Is it this one? No.
No. Slide 15. Slide 15.
Let me see if I know what that's. Slide 15 will not be exactly slide 15, man. Is it this one?
Yes, explain the one you just showed now before this page. No.
This one?
No, sir. Scroll down.
This one?
No, not this one. You showed it like this. Yes, this particular one. Yes, this one. The remote technology that is being suited to remote monitoring.
Okay. So the whole idea of deploying a mix of both management, software, and building technology is so that you can have what we call proactive FM maintenance, where you don't have problems occurring before you fix them. If you want to have a predictive approach to facility management, these are some of the technologies that help you do predictive. BIM and BAS, as I have explained, are very robust ways of gathering data for predictive maintenance. Remote monitoring also helps you to do predictive maintenance because it gives you data on the operating parameters and how things are changing within the assets you are monitoring. You don't necessarily need to repeatedly do preventive maintenance when you can do predictive. If you can keep getting data on assets and keep telling you that it's okay, it's working fine, you don't do any maintenance, and that's what predictive is about, isn't it? So using remote monitoring, integrating IWMS, which is a software that can be integrated to the building system, like I explained when I was answering Jonana's question. When you have BIM or BMS and BAS, and you integrate them into an IWMS, you'll be getting data directly from the source, directly from where it's happening. And with that data, you can make decisions whether to act in a way that would prevent that equipment from failing or not. The same thing with devices and drones. These are devices for seeing areas you cannot see. You know that some organizations actually have drones as part of their security system. Those drones will fly around and record at intervals, just the way a normal security man will go around the beat. These drones will do high-level surveillance, come back, charge themselves, get up and cycle and come back, charge themselves, go do their surveillance, and be doing that continuously. as part of their security. For some, it's just normal operations. The drone will observe how, for example, fountains outside are working, inspect sites for the way grass and plants and other landscape is behaving outside, watch for people behavior, in public places and things like that. So these are all ways of gathering data using technology so that decisions can be taken. If you want to be analyzing the data manually to act on them, it's okay. If you want to set up a system to automate how that data is responded to, it's also okay. That's what this is about. To prevent failures by gathering information through any of these methods.
Okay, very clear now. But the device and drones, we can't use, we thought of it before, but we can't use the drone here at the airport because it is restricted by the NCA. And if you will be using drone, you have to go and register it. The procedure is so long that you won't even bother to.
It's not really so long. It's not really so long. There's a control mechanism for a drone operator. All you need to do is find licensed drone operator. You don't have to put them on your payroll. They will help you use their certifications to apply for the license, and they will set up the monitoring for you, and they can actually train your team to act on the drone. And they will basically give the assurance to the licensing authority that they're the ones in charge of that drone. That's all. There are many people who are licensed to operate drones in Nigeria.
Thanks so much. And another thing is, as this technology as suite, I hope these employers will be able to invest in it, because it will save cost, but not at the start. But like all of them doesn't want to learn, because there was a time we raised a request for softwares to monitor our head office in Lagos, the Port Harcourt, the Warri. And the person that wanted to build the software was saying, okay, for a start, let them give him 700,000, and subsequently you pay like another 800,000. Everything has to cost like 1.5 million. They were like, oh, you're not the operation staff, you're only support staff, this sort of thing. And they came up with, so please continue using your manual, this thing. We are enjoying it like that. And that's how the innovation died, because that is almost like 80% of the employers, that is their thinking, that instead of me to be spending this so amount, let them do it manually. But it's like they don't understand it. But anytime you go to seminars, symposiums, which involves directors, board of directors, the airports tell them that they really need this thing. At least they usually appreciate what they learn outside than what you gave them inside here. There was a time where we said we needed trackers for our vehicles, because the transport department is the transport unit is under our department. Let's put trackers on. Say no. If you put trackers now, they know where the tracker device is. They can remove it and see the vehicle. And that was why they take down the tracking stuff. You can see the challenges we face in this environment, especially in Nigeria here. But this FM technology, if it's applicable in Nigeria, it would have been sweet. But I hope to see it.
You only need to just read the materials that we have shared, right? There are certain steps that can help you speak the language that management understands. If you don't already need, if the technology is not going to add value, don't propose it. You must establish what value it's actually going to bring before you propose it. And part of it is also to establish that you can actually deploy. Sometimes it's not only the money that makes them say no. Sometimes they know that you probably don't have the systems and the data to deploy properly. The money will be wasted. They'll say no. Sometimes you have not shown them exactly where the gap is between where you are right now and where you want to be, that this technology can speed you through. So those are the kind of things that hinders deployment. I mean, a deployment of 1.5 million, the organization cannot afford 1.5 million, and money is the real issue, then of course, this is not the time for it. because I don't see 1.5 million as a significant investment for technology compared for a software right now, the way the cost of technology is going up, you know. But if that organization does not need it yet, doesn't need it yet, you keep working manually, keep improving your processes and getting to a point where you can actually speak to the fact that it is now needed because you have generated a lot of data, and because of this work you are doing, you need an automation, a system to automate that data collection and analysis. They will buy into it. You produce value first on the manual level, and then you now say, if I have software, I'll produce more value. Boom, you get paid for it.
I know with this course now, I will advance myself and speak with my course, the way we can represent them. And let's see how it goes. Thank you so much, sir.
Fantastic. Thank you. You're welcome. Ganana.
All right, so I just want to say this. I think part of the challenge with some of us is our presentation skills and our writing or communication skills. Like you said, there are languages you should speak with management. And today I attended a tender board defense. And in that tender board, our GCTO is a very technical person. Then the chief group financial officer, even if it's somebody with a finance background, he also thinks like an engineer. Sometimes from the kind of questions they will ask, if you are really not prepared going in to do a defense, you see that before your first three comments, your issue will just be struck out. So we also have to be creative in how we present some of these things. Then also what I've also realized, timing is key. As FM managers, we should also understand cash flow in our businesses. Like for me now, over the years, I know when certain heavyweight requests can be thrown to the business. We are a fertilizer producing company. So you are thinking of doing some of these projects during your peak farming season when sales is its highest. When the cash flow is there, then some of these things can get management attention. But it's not probably when we are just coming out from a turnaround maintenance, you are going to tell them about drone. So one thing I can assure you, for a certain amount for AC, I was able to make a clear case. And in their mind, they were saying, what you're asking for will not be enough.
Imagine.
So for me, it was a very big
Yeah, it is. It is. Well, you know, at the time they bought into it, they just realized, you know what, we need to do it all the way. Don't do any half measure around it. We fund it properly. That's how it goes. Well done. All right. Thank you, everybody. Have a nice evening. Right.
There's a question on the chat.
Good evening.
Questions?
Thank you. Okay.
Thank you.
We have a large number of assets. Please, how do we incorporate barcode tagging to these assets? Chimede, reach out to us. We can tag for you. We have barcode tagging. We show you how to do it. Yeah, you can get a simple barcode printer and then integrate it into a small application, not a very complicated one. And you can tag all your assets. It's something we offer. But let's have a chat, yeah?
Okay, so I'll chat around the letter. All right.
You're welcome.
Thank you. Good night.
Thank you very much.
Thank you, guys.
Good night.
Bye. Good night. Yeah.
Good night.